Hi everyone. In continuation with the previous video, I'm just continuing this combinational logic circuit implementation using multiplexer. In the previous video, I have given you two examples how to implement a logic function using multiplexer. Just two more examples, very important, which are recently considered from the question papers were given. So use 4 by 1 multiplexer. Use 4 by 1 multiplexer. Implement Use 4 by 1 multiplexer to implement f of a, b, c is equal to summation of m of 1, 2, 6 and 7. 1, 2, 6, 7. Okay, by seeing this, we can identify that there are three selection lines because whatever the input function is implemented with, those are considered as selection lines according to our assumption. But here, if you consider A, B, C as selection lines, that will give you total 8 inputs. Then it will become 2 power 3 is equal to 8 means 8 by 1 multiplexer. That is not the case here because it is clearly mentioned that use 4 by 1 multiplexer. That means only two selection lines must be considered out of these three. Only two selection lines must be considered from these three and one must be chosen as input. Okay. When lesser size multiplexer is given, then number of selection lines we should consider few of inputs as few of selection lines. I can write like this: few of selection lines as inputs. That is very important. So few of selection lines must be considered as inputs. Okay, in our example, it is given f of a, b, c. F of a, b, c. How many selection lines are there according to the given question? 3 selection lines. But the implementation is for only 4 by 1 multiplexer. So 2 power 2 means only 2 selection lines must be there. So in our question, 2 selection lines must be there. 2 selection lines must be there. And so 2 selection lines. So A and B I am choosing as 2 selection lines. 2 selection lines are considered as A comma B. And what about the C? And C could be considered as one of the inputs. Hope you understand. Okay, now let us see how it is implemented with the truth table first. So first let me take the truth table. See, everything is possible with the truth table. Truth table is the one which decides the entire operation. Okay, so first I am taking A, B, C, which are the actual selected inputs, selection lines. But now I am taking S0, S1 as B and A, and C is not considered as the selection line. So this is the output. Okay, so 000, 001, 010, 011, 100, 101, 110, 111. Okay, so now the output is divide the inputs into two sections because AB selection lines will match in these first two. See here 0, 0, 0, 0. That means when both are zeros, what is the output? What is the function given for us? Summation of m of 1, 2, 6 and 7. So where is 1? Keep 1 here. And 1, 2, 6 and 7. 6 and 7 means last two. And remaining all are zeros, which are there in the min terms list. They will be considered as ones and remaining all are zeros. Okay. So now look here. In the first slot, f is equal to same as c, third input. When a and b are zeros, nothing but when selection lines are zeros, output is equal to simply c. And similarly here f is equal to the complement of the third input c bar. And see here f is equal to, when selection lines are 1 zeros, c is 0 1, but outputs are 0 with respect to of the c input. So simply f is equal to 0. And here also irrespective of the c, when selection lines are 1 1, output is equal to 1. Okay, so the now first set d naught taken as c and d1 taken as c bar, d2 taken as 0 and d3 taken as 1. Okay, so now we can implement the logic diagram. So we have to consider a 4 by 1 multiplexer, 4 by 1 mux. 4 inputs are there. Those 4 inputs are d0, d1, d2, d3. See here d0, d1 are nothing but c bar. So c is the input. It is the complement of c bar, nothing but d1. And d2 is taken as 0 and d3 as 1, simply 0. And remaining a, b are taken as the selection lines, as I said, s1, s0, and this is the output f. Okay, so this is the way of designing a 4 by 1 multiplexer with the 3 selection lines, actually a, b, c. So by converting one of the selection lines as inputs. Okay, so truth table is very important here. With the truth table, we can implement in that way. Okay, and another important question, implementing higher order multiplexer like a 4 by 1 multiplexer, 16 by 1 multiplexer. Okay, use a multiplexer having 3 data select inputs to implement the logic function for the given function below. So implement okay, f of a, b, c, d. How many selection lines are there? 4 selection lines are there. So 2 power 4 means 16 inputs are there. Okay, summation of m of 1, 3, 4, 11, 12, 13, 14 and 15. Okay, so as there are 4 inputs, so 2 power 4 means 16 outputs are there. So 16 outputs are there, that is fine. But implement this function using our restricted multiplexer is 8 by 1 multiplexer. This is very important to know. Okay, here the size of the multiplexer is clearly mentioned. If size is not mentioned, directly we can take 16 by 1 multiplexer by connecting all the pins which are mentioned here to logic high. That will give you the exact replication of what the question is asked for. But now the condition is you have to implement this 16 by 1 multiplexer using this 4 by 1 multiplexer. What is the thing we need to follow? We should follow one of the selected lines as input. So consider one of the selection lines as input. Okay, so here a, b, c are taken as selection lines and D is considered as one of the inputs. D is considered as one of the inputs. Okay, then we can implement a 2 power 3. Selection lines are 3 means 2 power 3 means total 8 inputs are there, and D will be one among those 8. Okay, somewhere around. Okay, now let us consider the truth table. Consider the truth table for the function f. For the function f. So A, B, C and D, we are having the output f. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1. Okay, let me divide that into two sets each, where A, B, C are common. Okay, remaining I will draw in the next slide. See here, first set what I am taking S2, S1, S0. As I said in the previous slide, A, B, C are considered as the selection lines and D is one of the inputs. So D I am not taking as a selection line. Okay, see here, A, B, C when zeros, A, B, C first selection lines when zeros, it gives you the data D0. Okay, D0 is nothing but what is the output function? We have 1, 3, 4, 11. Keep 1, 3, 4 and 11. 11 is not there, so remaining are zeros. Okay, now see, f is nothing but D only. F follows the D input, and here also f is equal to D only. Here it is f is equal to D bar complement. Here it is f is equal to G irrespective of D. Okay, f is equal to 0 and remaining 1, 0, 1, 0, 0, 1, 1, 0, 1, 1. So 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so now it is A, B, C and D. Again divide that into 2 each. So what is F now here? It is given, question is given for 11, 12, 13, 14, 15. 11, 12, 13, 14, 15 and remaining all are zeros. So F is equal to 0 here. What is this? This is D1, D2, D3. Okay. D4 is 0 and D5. Simply it is D. This is D5 and F is equal to 1 here. This is D6. F is equal to 1 here. This is D7. So the pins are total 8 pins we have got. 8 pins only, D0, D1, D2, D3, D4, D5, D6 and D7. All these 8 pins are having corresponding inputs. So see, some of the inputs are in terms of D and D bar. That means one selection line D is taking as input. Hope you understand how to do a big circuit implementation like 16 by 1 using 8 by 1. So logic diagram is logic diagram. So 8 by 1 multiplexer 8 by 1 multiplexer with three inputs, selection lines A, B, C, S2, S1, S0, A, B, C, and total 8 inputs D0, D1, D2, D3, D4, D5, D6, and D7. So what are the connections now? D0 is connect D0, D1, D. D0, D1 connected to D. Next, D2, D bar, D3, 0. D2, D bar. This is not get D2. D3 is 0. Next, D4 is 0, D5 is D. D4 is also 0, D5 is D. D5 is D. D6, D7 once. D6, D7 combine together and we can give it to 1. Okay, and this is the output F. This is 8 by 1 mux. Okay, this logic realization is very important. In the examinations also, you are asked to implement such type of 8 by 1 multiplexers with the F of A, B, C, D. Okay, what we have seen like 16 by 1 multiplexer design. Okay, thank you.